this section, we'll learn how to solve rational equations and work with formulas. Recall, you can multiply both sides of an equation by anything except 0, and the equation will still be true. For example, in this problem, we're supposed to solve and check our answer. We could multiply both sides of this equation by 5. We could multiply both sides of the equation by 7 if we wanted. But if we multiply both sides by 4, watch what happens. The 4 over here cancels. Here, the 2 cancels and goes twice. We have 2x equals 3. Now we have rid of the fractions. All we have to do is divide by 2 and we get 3 halves. The trick is to multiply by the LCD of the fractions in the problem. Now when we check this, we'll have 3 halves divided by 2 equals 3/4. If you remember, we can go ahead and simplify this compound fraction by multiplying by 2 over 2. 2 cancels the 2, and 2 times 2 is 4 on the bottom, so we're left with 3/4. It made the equation true, therefore that is our answer. When we have variables in the denominator, we'll need to make sure the value we find for x is allowable. In other words, we can't allow a value of x that makes any fraction undefined in the problem. For this problem, the LCD is 2x times x plus 2. What happens here is we multiply both sides by 2x and x plus 2. On the left side, 2x cancels. On the right, x plus 2 cancels. And then we have 5x plus 10 equals 16x. Then we're rid of the fractions. We'll have 11x is 10, and dividing by 11, we get x equals 10/11. Now we don't have to check to make sure that we haven't made a mistake. The kind of check that we're looking for is that we check to make sure that this doesn't make any of the fractions undefined. The only values of x that would make this undefined is a value of 0 or a value of -2. Since this is not either one of those values, we can be safe to say that that is the answer, as long as we haven't made any mistakes in the process of solving. You may have noticed, or done this in the past, where you have a fraction equals a fraction, and you just cross multiply. Let's talk about why we can do that. The underlying principle says that if a over b equals c over d, with b and d not 0, then a times bd over b equals c times bd over d. We're simply multiplying both sides of the equation by bd. What happens is that our b's cancel, our d's cancel, and we get AD equals CB. In this way, we see that the cross products of a proportion are equal. A proportion is when a fraction equals another fraction. So we can use this principle and just cross multiply to solve for simpler equations like this one. Let's try that principle here. I have a fraction equals another fraction. So I can just cross multiply. 3 times n minus 5 equals 2 times n plus 5. Now multiplying out, I get 3n minus 15 equals 2n plus 10. That gives me n equals 25. Now we just need to check that the value that we came up with for n does not make any of the fractions undefined in the original problem. The only values of n that would cause the fractions to be undefined would be a -5 or a +5. That way we can say we're safe with n equals 25. With this one, you can still use that cross product principle. Just remember that -z has a denominator of 1. Now when I cross multiply, I get 1 equals negative z times z plus 2. When I multiply this out, you'll see that I'm going to have a quadratic equation. This means I'm going to have to get everything on one side equal to 0 and factor. So let's move this all to the left. Z squared plus 2z plus 1 equals 0. Now we factor. Z plus 1 equals 0. Of course, both of those factors are the same, so we have just one answer, z equals negative 1. Now checking, if we would put a negative 1 in for z, it does not make this fraction undefined. And over here, the z is in the numerator. We're still okay over there. So z equals negative 1 is our solution. We can use the cross product principle here. Negative 1 times 3 is negative 3 equals 2x squared plus 5x. Again, we came up with a quadratic equation, so we're going to have to set everything on one side equal to 0. Now I want to factor. Let's split up the 2x squared as 2x and x. Let's break up the 3 as 3 and 1. Both are positive. Let's check the middle term. 2x and 3x is 5x. Now we have 2x plus 3 equals 0, or x plus 1 equals 0. Solving each of these, I get x equals negative 3 halves, or x equals negative 1. Let's double check and make sure those answers are allowable. So we'll look here. If I would put a negative 3 halves in this, I'd get a negative 3 plus 5, which is not 0. So we're okay there. If I put a negative 1 in here, that's a negative 2 plus 5, which is 3, which is not 0. So we're still okay with that answer. Both answers work here. So what happens when we have an equation like this? This is not a simple proportion where one fraction equals another fraction. Then we'll have to go back to the principle of multiplying both sides by the LCD. Here are the steps outlined. First, find the LCD of the terms in the equation. Then multiply each side of the equation by the LCD. Simplify each term, and then solve the resulting equation. Check each answer in the given equation. Any value that makes the denominator equal 0 should be rejected because it is an extraneous solution. Let's solve the equations and check your answers using the steps outlined above. In this problem, I see I have a denominator that is not factored, so my first task will be to factor that denominator so we can see what it's made of. Now you can plainly see the LCD is x plus 1, x minus 1. I'm going to multiply each term of the equation by x plus 1, x minus 1. So I'll have 2 over x minus 1 times x plus 1, x minus 1 plus 1 times x plus 1, x minus 1 equals 4 over x plus 1, x minus 1 times x plus 1, x minus 1. Now let's get ready to cancel. I can cancel this x minus 1 here, and the x plus 1 and the x minus 1 over there. Now let's multiply what's left. 2 times x plus 1 is 2x plus 2, plus 1 times x plus 1 times x minus 1 is x squared minus 1, equals, everything over there canceled, we have a 4. Now I see I have a quadratic equation. I'll need to get everything on one side equal to 0. X squared plus 2x, and 2 minus 1 is 1. When I subtract 4, I'll have a negative 3 equals 0. Factoring that, I'll have x plus 3, x minus 1. So x equals negative 3, or x equals 1. can we allow both of those solutions? If I would allow x to be -3, -3 minus 1 is -4. We don't have a 0 there. If I allow it to be a -3 there, -3 squared is 9, minus 1 is 8. So I don't have a 0 there. Of course, the -3 will be alright. What about x equals 1? If I allow x to be 1 here, we'll see we get a denominator of 0. So we can't allow x to be 1 in this problem. Let's try that strategy again with this problem. Here I don't have unfactored denominators. I can go ahead and find the LCD. The LCD will be 5y, y minus 1. Let's multiply each of the fractions by the LCD. Now let's cancel what we can. We'll have a y minus 1 that cancels. Here, a y cancels. And here, my 5 cancels. Let's multiply what we have left. We'll have a 20y plus 5 times y minus 1 is 5y minus 5 equals 6 times y minus 1 is 6y squared minus 6y. Again, we see we have a quadratic equation. We'll need to get everything on one side equal to 0. So I have 6y squared and negative 6y. When I subtract 5y, I'll have a negative 11y. And then when I subtract 20y, I'll have a negative 31y plus 5. Set it all equal to 0. Now let's factor. Let's break up the 6y squared as 6y and y. About a 5 there and a 1 here. We'll need both signs to be negative. That gives me a negative 30y, and a negative 1y is negative 31y. Setting each of those factors equal to 0 and solving those simpler equations, I'll have y equals 1/6 or y equals 5. Are both of those answers allowed? If I allow y to equal 1/6, I won't have a 0 here, and I won't have a 0 here. So y equals 1/6 is fine as a solution. Can we use y equals 5? 5 minus 1 is not 0, and 5 here would not be 0. So y equals 5 is also a solution. Please note, you can only clear fractions as we've done here if it is an equation. If we're just adding or subtracting fractions, as we've done in some of the sections before this, you cannot clear fractions. But because we're working with equations in this section, we can multiply by anything that we'd like except for 0. Here I see I have another denominator that needs to be factored. Let's go ahead and factor it so we can see what everything is made of. Then we'll find the LCD. It's plain to see here that the LCD will be p plus 1, p plus 2. Now I'm going to multiply each of those fractions by p plus 1, p plus 2. Let's get ready to cancel now. I'm able to cancel my p plus 1 over here, my p plus 2 here, and both p plus 1 and p plus 2 in the last fraction. Now I'll have just a p plus 2 here plus a p plus 1 equals 1. Here I don't have a quadratic equation, so I just solve like it's a simple equation. 2p plus 3 equals 1. 2p equals negative 2. P equals negative 1. Am I allowed to use negative 1 as a value of the variable? If I use a negative 1 here, I'll have a 0 in the denominator. That's not allowed. So we can't use that solution. There's no other solution to choose from, so this problem will have no solution. Now let's use what we've learned for solving a formula for a variable. In this formula, we have m equals 2k over v squared. We need to solve for k. First of all, we have a fraction, so we can clear a fraction because it's an equation. I can multiply both sides by the LCD. The LCD is v squared. That gives me a v squared m on the left. On the right, my v squareds cancel, and I have 2k. Now, as I'm trying to solve for k, all I have to do is divide by 2. So k equals v squared m all over 2. Now we have a new formula that's solved for k. In this formula, I'm solving for b. We'll start it out the same way. We're trying to solve for b, but we have fractions, so let's clear the fraction. Multiplying by a plus b. Here we can also see you can cross multiply. If I just cross multiply, I'll have TA plus TB equals AB. Remember, we're solving for b. I have a b on this side and a b on that side. If I'm going to solve for b, I'll need to have my b's on the same side. So let's subtract TB to get our b's on the same side of the equation. That will give me TA equals AB minus TB. Now I need to find a way to get the b away from all the other things it's with. Can you think of how we would do that? We simply factor out the b. Once you do that, you'll see quite plainly what you need to do to solve for b. We simply divide by a minus t. Now that factor cancels, and we have b equals ta over a minus t. Make sure that when you're solving a formula for a certain variable, that you don't have that variable in the formula. It should be the variable you're solving for equals a combination of other variables and numbers. Let's solve this formula for x. First, we cannot use cross multiplication here because we have 3 fractions, not just a proportion where one fraction equals one other fraction. So I'll need to multiply by the LCD. The LCD is kxy. Let's multiply each term by kxy. Let's cancel what we can. The k cancels, and I have 3xy equals, the x cancels, and I have a ky, minus y cancels, and I have 2kx. Remember, we're solving for x. I'll need to get this term on the other side because the x's need to be on the same side. So 3xy plus 2kx equals ky. Remember, we're solving for x. We need to pull it away from the other things that are with the x. So let's factor. X out, we get 3y plus 2k. Now I just need to divide by 3y plus 2k. That gives me x equals ky over 3y plus 2k. Remember, check and make sure that the formula doesn't have the variable in it that you're solving for. Now we'll look at applications called work rate problems. Here's an example of a work rate problem. Painting a house. One painter can paint a house in 8 days. Yet, A more experienced painter can paint the house in 4 days. How long will it take the two painters working together to paint the house? If we had just the first painter painting the house, we know that the house would be finished in 8 days. If we had just the second painter painting the house, we know we'd be finished in 4 days. However, finding the time it takes for them to work together is a little bit more of a problem. What is the rate that the first person can paint the house? Isn't it 1/8? They're painting 1/8 of the house every day. The more experienced painter is painting at a rate of 1/4 a house a day. The thing is, we're not sure how long it's going to take them together to paint the house. So what we do know is it's going to take them a certain time to paint the house together. The first painter does T over 8 of the work. The second painter does T over 4 of the work. If we take the fraction that each one of them painted on the house and add them, they will have painted one house, or finished one job. If we can solve this for T, then we'll know how much time it took them together. A general formula is T over A plus T over B equals 1. T is the time spent working on the job together. A is person A's time. And B is person B's time. All you need to do is put the appropriate numbers in the formula and solve. Let's go back to our house painting problem. One painter can paint a house in 8 days, and a more experienced painter can paint the house in 4 days. How long will it take the two painters working together to paint the house? We start with our formula, T over A plus T over B, and it equals 1. The thing we're solving for is how much time it takes together to paint the house, so T will be our variable. T is the time that it takes together to paint the house. Now we just need to substitute the appropriate values in for A and B. That gives us T over 8 plus T over 4 equals 1. Now looking at this, I see the LCD is 8. So I'll multiply each term by 8. 8 cancels 8, and I get T, plus 4 cancels 8 twice, I have 2T, equals 8. Solving, I get 3T equals 8, and T is 8/3. We wouldn't leave our answer like this because it's a word problem. We need to go ahead and turn this into a mixed number. 8/3 is the same as 2 and 2/3. And what is our label? It's a time label, and we know that the time was in days. So this will be 2 and 2/3 days. Distance rate time problems. This one is on river current. A boat can travel 36 miles upstream in the same time that it can travel 54 miles downstream. If the speed of the current is 3 miles per hour, find the speed of the boat without a current. We have two situations. We have the situation where the boat is going upstream, and the other situation is where the boat is going downstream. Now we have distance equals rate times time. I'm going to fill out this chart with whatever is given to me in the problem. In the upstream trip, we have the boat traveling 36 miles, so we'll put that under distance and across on the same line of upstream, 36. Traveling 54 miles downstream. So, underneath distance and in level with downstream, I'll put my 54. The speed of the current is 3 miles per hour, where to find the speed of the boat without a current. Right now is an appropriate time to define your variable. What are we going to let x represent in this problem? We know the speed of the current is 3 miles per hour. We don't know the speed of the boat. So let x equal the speed of the boat without a current. Now think about going downstream. If the speed of the boat is x and the speed of the current is 3 miles per hour, then my overall speed would not be just x, it'd be 3 miles per hour faster. So its overall speed is x plus 3. Going upstream, my boat is trying to go x miles per hour, but the speed of the stream is pushing against it 3 miles per hour. I'm not given anything in time except that the problem says that this trip upstream and downstream is done in the same time. I do know that time is distance divided by rate. To see this, let's take the formula distance equals rate times time and solve it for time. We'll divide both sides by r, and t equals d over r. Now let's take this distance, divide it by this rate, and that will be the time that we put in the chart. Here I'll take this distance and divide by its rate, x plus 3. Now the problem says that the trip upstream and downstream is done in the same time. That means this time is equal to this time. Now we see we have an equation. 36 over x minus 3 equals 54 over x plus 3. Now we have a proportion where a single fraction equals a single fraction. We can simply cross multiply, which gives me 36x plus 108 equals 54x minus 162. Now we need to get our x's on the same side. So let's subtract 36x from both sides and add 162 to both sides. This is going to give me 18x on the right. On the left, I'll have 270. Now I'm ready to divide by 18. When I divide 270 by 18, I get 15. X equals 15. Let's make sure that this makes sense in the context of the problem. If I'm going upstream, I have 15 minus 3 is 12 miles an hour going upstream, and 15 plus 3 is 18 miles per hour going downstream. So we know that the answer is 15 miles per hour. A similar distance rate time problem is an airplane speed problem. It's just that the travel medium is now air instead of water. An airplane can travel 450 miles into the wind in the same time that it can travel 750 miles with the wind. If the wind speed is 50 miles per hour, find the speed of the airplane without any wind. So now we have two different situations. We're traveling into the wind and traveling with the wind. Into the wind is the same thing as against the wind or against a current. So we're going into the wind and going with the wind, where the wind is helping us. Distance equals rate times time, and let's fill out our chart. We have 450 miles into the wind, and we have 750 miles with the wind. The wind speed is 50 miles per hour. Find the speed of the airplane without any wind. Let's go ahead and define the variable. We're going to let x equal the speed of the airplane without wind. Now, if I'm going with the wind, I know my plane is going x miles an hour, but the wind is pushing it an extra 50 miles per hour, so it's x plus 50. Into the wind, I'm trying to go x miles per hour, but the wind is pushing me back 50 miles per hour. The same as we did last time, we know that time is distance divided by rate. So this time is 450 over x minus 50. This time is 750 divided by x plus 50. Reading the problem again, we see that we can travel 450 miles into the wind in the same time that it can travel 750 miles with the wind. This means that, again, my times are equal. 450 over x minus 50 equals 750 over x plus 50. Now that I have a proportion, I can go ahead and cross multiply. 450 x plus 22,500 equals 750 x minus 37,500. Now I'm going to get my x's on the same side, any terms that don't have a variable on the other. This gives me a 300x on the right, and on the left I'll add 37,500. This gives me 60,000. Now when I divide by 300, I'll have 200. So the speed of my plane without the wind is 200 miles per hour. This problem is a word problem consisting of just simple substitution and interpretation. If a car is traveling downhill at 30 miles per hour on wet pavement, then the braking distance b in feet given for this car is given by b equals 30 divided by 0.3 plus m, where m less than 0 is the slope of the hill. Find the braking distance for m equals negative 0.05 and interpret the result. All we need to do is substitute negative 0.05 in for m. So in part A, I'll have b equals 30 over 0.3 plus a negative 0.05. That is 30 divided by 0.25. So b equals 120. Let's make sure and label the answer. We were finding the braking distance, and the braking distance was given in feet. So this will be 120 feet. In part B, find m if the braking distance is 150 feet. The value that they've given us is not m. It is a braking distance, which is b. So we'll put 150 in for b. Now we need to solve for m. If you want, you can go ahead and cross multiply. We'll have 30 equals 45 plus 150m. Now we need to subtract 45. That gives me a negative 15 equals 150m. Dividing by 150 on both sides, I get m equals a negative 0.1. So m has a value of negative 0.1 if the braking distance is 150 feet. Go ahead and try the homework and let me know if you have any questions.